Okay, so we're going to play a game. We're going to play a game. Everyone's got some cards. I think, Becky, you've been very quiet. Would you pick a card? So what are we doing here? At the top is the, on the back is the pillar we talked about in the beginning around what we do, data center awareness, enterprise performance. On the other side is an action, a policy change, a thing that would happen within the infrastructure. So this could be driven by ecosystem. It could be driven through administrative tasks. But instead of me going through and just showing stuff, we wanted to get the delegates more engaged. So Becky, do you have one to throw down?
Add network IP pool.
Great. So what are we talking about here? So first I'm going to log into the Datera user interface. This is what an administrator would see with their on-premise deployment across servers. They would log in through a local user or using an LDAP server. This I'm using an LDAP server. This is our user interface. This is running live in our demo environment. Lots of information. I logged in as an administrative user, not as a tenant or a sub-user. When we start talking about this concept of a network pool, we've talked a lot about being aware of the data center, being able to do multi-tenancy, be able to do segregation. One of the ways segregation happens is quite obviously through the networking. This particular system is deployed using our layer 3 technology, so you're not going to see VLANs. The expectation is that the routing engine in the data center is routing that particular user's network to the network on the Datera side. So this is very simply the UI. Everything you see here can be done through the API as well. And what I'm going to do is navigate to what we call the pools page for the network address IP pools. Again, iSCSI for block, S3 for object. I'm going to hit the create new button, very simply. And we're going to just provide the information, just make some stuff up. So this is Storage Tech Field Day 18. We talk about multi-tenancy. One of the challenges is around controls of policies. How do I ensure that if you ask for something, it's in the right place, versus when Chris asks for a resource? We can do that through these policy sets, through the multi-tenancy. So actually, I'm going to make this even dangerous. So what I'm doing is I'm giving it a keyword, default. So the default network for that given tenant will be this network. So I'm going to go ahead and pick one of these, which I think is empty. I think this guy, because it actually changes stuff. So I'm going to say I want 64 IP addresses, and I'll just make up an address range of 10.150.0.1. So what it's going to do is allocate 64 address pools. Why do we do this? We manage those resources. We talk about storage protocols. Most storage protocols today are v4 unicast. That's what they are. By building the IPAM into the cluster, into our system, I can onboard NFS, rsync, FTP, and I can orchestrate that, make it available with all the technology I have today. I don't need to add anything to bring in any kind of protocol on the front end. We can just turn it on. So I'm going to give another range here of 64, and I'm going to give it another block. And of course, it's a live demo. So what is going to happen is there's going to be a new pool called default. It's going to be in the OpenShift tenant. Anytime the OpenShift tenant provisions a resource, our system will enforce. It draws the network from those range. And you can have dozens of IP ranges so that as you start thinking about that system being operated with different technologies, you can segregate those networks out. Okay. So now, from the UI perspective, I have two defaults. So it is a little confusing. But I have two defaults, but they're in different tenants. So if we were to create an instance in the OpenShift tenant, it would say default. And it would draw from this pool, even though everybody else in the system would draw from the other pool. Thank you. Thank you, Becky. Anyone else?
And how many, in that scenario, in your environment, scalability of tenants?
Hundreds.
Hundreds, okay.
Yeah.
So you could expect that to be populated with hundreds or more of entries for various different networking setups.
Yes, and again, everything is API. I can actually go back and look at the user event, and we can look at the API call that drove that. This is the JSON file that is used to produce this event.
Yeah.
So if I wanted to automate it, I can do it once. We have an Explorer as well. I'm done. I can automate all of this stuff by doing it once.
And we can audit. You've got a full audit trail.
Thank you.
Who's got another card to play? I think we
It's not
got
about
time, just
doing it,
one
it's about
more.
auditing it.
Yes.
Okay. Is there another card? Anyone?
I'll throw down a data placement change.
Okay, data placement change. Thank you. So what are we talking about here? We talk about the system being driven by policies. The data placement is very important. So I'm going to navigate here to our storage nodes. What you're going to see, it's a little small. Hopefully you can read that. My first one here, the order of which I created the system, is Intel Optane. We love Intel. The Optane media is fantastic. 3D point crosspoint is very, very, very fast. I have a server. It's a physical server. It's a 1U server. It's got Intel Optane media. I have created a label called Optane. I assigned it to this. So Ray was asking about the persistent class memory and the containers and the storage attributes in Kubernetes. In a similar way, we label the components within our technology, and as they come in, you can choose those labels, you can set the failure domains, all of that happens through this administrative interface. There's a little bit of detection that can happen, but you can override. So I have Optane, I have all flash, and I have hybrid. That is what I have right here. And we've said it a few times that the technology is about abstraction. The way you gain agility, I don't think I've plugged this in, the way you get agility is through abstraction. Because the more you can abstract, the more you can change, which is why everything is a UUID and the human name is a label, right? Because you want to be able to change the human name as much as you can, and you don't want the humans to care about the UUID. It's very, very common. So what we're going to do is navigate to the policies section of the user interface. Here I have my media policies. This is my physical hardware. We support, I think, up to 64 different labels in terms of media policy, and we order them. Who is fastest? Number one is fastest. And I can inject at any point a number and we'll shift. We can do this automatically in our technology. So you can imagine if I bought a new server. Let's say I bought a read-intensive SATA device. Well, I want to be careful with that because it's not for every workload. I add that, I give it a priority of 3, and then hit submit. And now I have a new media policy. It's there, but it's not assigned to any physical servers. We could do that, but now I have that policy. So if I go to the placement side, we take those labels, and now we create, again, user-facing things on how the system consumes those technologies. Now, one of the things that we do, which is fantastic, is you can build all of this policy set and have none of the physical hardware. Make that very clear, because this is a challenge. Let's go back to our enterprise friends when I talk about enterprise. They typically will they'll onboard a product. They will put it everywhere. That same exact thing with all the same parts. Even if they only really need it in a couple places, but they want to have it in other places for policy sakes, with our technology, they can have the Datera software, but the physical hardware can be the right stuff. I don't have to have these various technologies in order to use this policy engine. So what I have here is a number of different predefined policies. To make them simple, we use precious metals, gold, bronze, silver. I can sort by that, or sort by root and tenant. So what I'm going to do is I'm going to pick the silver policy under the Kubernetes tenant. Remember we talked about IP pools and how it overrides that selection? We can do the same thing on the media side. So go ahead.
So basically what it means is I can tie my hints back to silver, and it will actually pick up tenant-specific hints based on the same naming nomenclature across the board.
Yes.
So we don't have to say, I'm tenant X. It'll inherit that.
Exactly correct. Thank you.
Can I sync these policies across multiple clusters?
We don't offer that technology, but it's all API. So it's a matter of reading the JSON and spewing it out. It's very simple to do. Okay. That's the nice thing about being API first, an API built in. But it's exactly right. So if we just look at this user interface, you can see that the silver policy for the Kubernetes user, that one person, is based on all hybrid. If we go back and look at the silver policy for everybody else, you can see I feature my Intel Optane and all flash. And that's a label. We could change this to any other label that we've created. One other interesting things to introduce right here at the end is we get even more fun because we have a minimum and a maximum. Remember I talked about the on-premise analytics that we can do? Through this policy engine, the administrators can choose, I want to start on flash, but if the workload warrants it, I want it to automatically promote it into Intel Optane. Again, these are labels. This is what I physically have. You can make up any words, bananas, apples, it doesn't matter. This is your enterprise, your organization, your terms. You can apply them to this product, and now you get that consistency. So let's go back to our Kubernetes friend here, and let's just change this. And instead of making the max hybrid, we'll make the max flash. So what will happen over time, we weight the volumes against each other. If one of their volumes is doing a lot of read I/O relative to its size, the system can automatically promote that. Our analytics platform can provide this information in a review format. So you can say, what should I be doing? When do I need to buy more flash? Because we have the policies and we know the physical infrastructure. Now, that next cycle of purchase, it's January 1st. My budget's going to end on March 31st. What am I going to buy? What am I going to submit? We can get very precise based on what's been provisioned, how the analytics are running, what the system looks like, so you can buy the right thing. Do I need Optane? Maybe you don't. Maybe you do. Don't know. So I'm going to hit submit here. And now we've automatically updated that policy. And now that policy change has rippled through the whole system. Any place that this particular user has selected the silver policy, it has now been changed for them. Okay?
So what's the process for something moving automatically, like from solid state to Octane?
So the way it works internally, and we have a lot of other videos on this topic because it is a little bit expansive. This is the heart of our technology. I talked about intelligent placement. Targeted placement. That's what that technology does. It allows us to take a volume, and I can show it this way. Let me open up one of the larger instances. This is pretty big. And I can scroll down in the user interface, and you'll see a list of the servers that one is targeted to. As you know, there are more servers in the system, but the way our technology is designed is we sort of manage that metadata to say, this particular volume, at this time, its policy set means it should go on these servers. And as we change those policies, there's an engine underneath that allows us to non-disruptively move the components of that volume around. So think of VMware vMotion. Fantastic. In the storage world, as someone selling storage, I love it. You have one array, you want another array, right-click, you can onboard my technology. We can bring this capability at the storage level to bare metal. I can have a bare metal database running on hybrid, as an example, move it to all flash, move it to NVMe flash, move it to Optane over the next 5 years.
I guess the question might have been more, how does it handle it automatically? So you had one class there that had both hybrid and all flash, minimum and a maximum class, and then how would you decide when to move something that was on a minimum structure like hybrid to an all flash?
Sure, Ray. So it really goes back to the reads per gig ranked against the other volumes.
In that class?
Yes, in that class. So only things that have this capability. The control plane has a process called an optimizer, and it optimizes the system for everything. Capacity rebalance. This is the performance optimization. As new technology comes into the system, what do I do? How do I onboard something? Because everything's policy driven, the system can make those decisions without the administrators having to be intimately involved. We'll use that term. It's no more stacking shelves, creating RAID groups, plugging in the drives, and hope it works.